Hey guys, we are going to start out our mole unit and we're going to look at how we can measure matter in different forms and how to convert between those different forms using dimensional analysis. So looking at how we measure matter, we're going to look at the quantity of matter. This is going to be dealing with how many particles we have, things like that. We're also going to look at measuring matter by its mass and by its volume. So one thing we're going to use throughout this unit is moles. A mole is a bulk unit because it's very hard to count individual particles or atoms, so we use a bulk unit. This is similar if you buy a dozen eggs. You know a dozen means 12. If you have a ream of paper, that's 500 sheets. So it's one of those bulk units similar to that. So mole is an amount equal to 6.02 times 10 to the 23rd representative particles of a substance. This is the known quantity no matter what the substance is. 1 mole of anything is going to be equal to 6.02 times 10 to the 23rd particles. And this is Avogadro's number. On your reference sheet, it is the very first value that's given. And this was named after Avogadro, who determined the difference between molecules and atoms. So that is a known number that we're going to use as a conversion factor. What it means by representative particles. Um, so depending on what substance it is made up of individual particles. Um, if the particle is an atom, these are the representative particles of elements. So the smallest part of that element would be the atom. This can be anything straight off the periodic table, like iron, carbon, lithium, manganese, mercury, anything like that. If the representative particle is a molecule, this is the smallest part of any type of molecular substance. So this could be our diatomic molecules like oxygen, hydrogen, fluorine, chlorine, or any molecular compounds that, remember, only have nonmetals in them, like the silicon dioxide or water. If our representative particle is a formula unit, that means that this is some sort of ionic compound. Um, so it could be potassium chloride, lithium hydroxide, or silver nitrate. No matter what type of particles we have, it's always a mole of particles is equal to that Avogadro's number. So the 6.02 times 10 to the 23rd particles per mole. So we're going to look at how we actually use this number to convert between amount of substances. So if you watched the dimensional analysis video yesterday, remember the whole process of dimensional analysis is to allow you to cancel out your units to convert your units but have the same quantity of stuff that you started with. So our conversion factors, we know that 1 mole of anything is equal to 6.02 times 10 to the 23rd particles. So that can be used as one of our fractions to convert between different substances. So here's an example and we're going to work through it together. Magnesium is a light metal used in the manufacture of aircraft, automobile wheels, tools, and garden furniture. How many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? So remember we said you always want to start with the amount that you actually have of what's given in the question. So it tells us that we have 1.25 times 10 to the 23rd atoms of magnesium. And I'm just going to abbreviate atoms. And it's asking us how many moles of magnesium this is. So remember, we are getting rid of atoms because we're looking for moles. So in our next conversion, atoms needs to be on the bottom. That way it's on top of the line and below the line somewhere, and we can cancel out that unit. So atoms is going to go on the bottom, and we're going to change into moles because that's all that we know. And from our conversion factor, we know that 1 mole is that 6.02 times 10 to the 23rd atoms. So that will cancel out our unit of atoms, leaving us with moles, which is what we were looking for. So we're done with our setup. We need to type in the calculator. Here's where it can be tricky because your calculator sometimes will not do the proper order of operations that you want when you have numbers in scientific notation. So you either want to make sure that you put both numbers in scientific notation in their own set of parentheses, or you want to use the EE button on the calculator. So you can type this in, open parentheses, 1.25 times 10 raised to the 23rd power, close your parentheses, and then remember any number on the bottom gets divided by. So divided by, open parentheses, 6.02 times 10 to the 23rd power, close parentheses. If you type it in that way, you get that it's 0.208 moles of magnesium. And always make sure to put your appropriate unit. Another way that you can type this in is using the EE button. On the calculator, the EE button stands, oops, let me scroll down so you can see this part. That EE button stands for times 10 caret. So whenever you use that button, it takes out some of those buttons that you have to hit. On all TI calculators, this is located as a second function to the comma that's right above the 7 on your calculator. So when using this button, you only need to type in the coefficients and then the exponents. So if you use the EE button, you're going to type in 1.25, hit second EE, and it pops up a single E on your screen. And then type in your exponent, the 23. That will be divided by 6.02, second EE, 23, and then it still gives you 0.208 moles. So you figure out which way you like to type it in, either using the parentheses or the EE button. But note that if you do not use one of these, it is likely to give you a wrong answer, even if you have the correct setup. Let's look at another problem. How many molecules is 0.360 moles of water? So we're going to be using that same conversion factor of 1 mole is equal to 6.02 times 10 to the 23rd particles. But remember, you're always going to start with what is given. So you're given 0.360 moles of water, and we want molecules. Make sure that you abbreviate moles and molecules differently so you ensure that you've canceled out the correct units. So we're looking for molecules, so we no longer need moles. Since it's on top, that unit needs to move to the bottom so it can cancel out. And we can go straight from moles to molecules or particles. So remember that 1 mole is equal to the 6.02 times 10 to the 23rd molecules. So that cancels out our unit of moles, leaving us with molecules, which is what we were looking for. So we need to put this in the calculator. So since both numbers are above the line, you're going to multiply them. So 0.360 multiplied by 6.02 times 10 to the 23rd. And remember, sig fig wise, you can pay attention to however many digits you started with. So since our original number had 3 digits, our answer we can round to 3 digits. So the calculator gives us 2.167. So we'll round that to 2.17. That's times 10 to the 23rd. And make sure to include your unit of molecules on there. We're going to go through some more examples of these. Feel free to pause and try them on your own if you would like. Alright, so with this one, how many moles is 2.8 times 10 to the 24th atoms of silicon? So remember, you're going to start with what is given. So we have 2.8 times 10 to the 24th atoms. And we're trying to find moles. So we need to get rid of atoms. So since it's currently on top, it will move down to the bottom. And we're always going to change into moles first. So remember, 1 mole is equal to 6.02 times 10 to the 23rd atoms. That cancels out our unit of atoms, leaving us with moles. So now we simply have to put it in the calculator. Remember, so you have to punch in your original number, the 2.8 times 10 to the 24th. Don't forget about your parentheses or the EE button, whichever way you like to use. And since the 6.02 is on the bottom, we are dividing by 6.02 times 10 to the 23rd. With our sig figs, so 2.80 is 3 digits. So yet again, we can round our answer to 3 digits. So you should get 4.65. If you did not get 4.65, check and see if you put those numbers in scientific notation, particularly the 6.02 times 10 to the 23rd in parentheses. And always include your unit. So that will be moles. All right, let's try this one. How many atoms are in 1.12 moles of silicon trioxide? So same deal. Always start with what is given. We have 1.12 moles. And we are trying to get to atoms. So we no longer need moles. So that will move to the bottom in our next step. And atoms will be on top. Remember, our conversion is 1 mole is always the 6.02 times 10 to the 23rd atoms. That cancels out our unit of moles, leaving us with atoms. So we need to put that in the calculator. Since both numbers are on top, we need to multiply them. So 1.12 times the 6.02 times 10 to the 23rd. And we had 3 digits originally, so our answer can have 3 digits, is 6.74 times 10 to the 23rd atoms. Okay. And that is where we are stopping today. Make sure to try using this process and make sure that you're always showing your work and allowing you to cancel out your units.